Hello everyone, welcome back to the channel. Let's discuss this problem. Now this question is related to the chemical kinetics. Let's see. Here we are given a reaction A to B and its rate expression is given as R is equal to 2A upon 3 plus A, right? Where A is the initial concentration at any time T. Few statements are given to us A, B, C and D and we need to find which one of the following is correct one. Now we can do one thing, how to approach this problem. We can easily solve this rate equation in the terms of concentration versus time, right? So R is given as 2A upon 3 plus A, where rate can also be written in the terms of minus dA upon dt. So minus dA upon dt is equal to 2A upon 3 plus A. Now taking the concentration terms on the one side and time term on the another side, we will approach and reach this point. The integral limits will be at t is equal to 0, let's say the initial concentration is A naught, at any time t the concentration is A, right? Upon further solving it, we'll reach to this limit. Now here, upon performing the integration and putting the limit values, we will obtain 3 times ln of A upon A naught plus A minus A naught is equal to minus 2t. This is the equation we obtain, right? So this is the final equation of the rate equation which we have for this equation. Now first point says the plot of half lifetime versus A naught is a straight line with the slope of 0.25 and intercept of 1.05 on the y-axis. So half lifetime is what? Half lifetime is the time for option A. Let's solve it. Half life is the time when we know A is equal to A naught by 2, right? So if I put this value into here, so it will be 3 ln A will be A naught by 2 A naught plus A naught by 2 minus A naught is equal to minus 2t, right? So it will be 3 times ln. Now it will be 1 by 2, and if I want to convert it into ln2, we will have to put the minus sign here. So minus 3 ln2 minus A naught by 2 is equal to minus 2t, right? So it will be, all the signs are negative, so we can easily convert it into the positive by cancelling it. So it will be A naught by 2 is equal to 2t minus 3 ln2, right? Finally, A naught is equal to 40 minus 6 ln2. This is the equation we have obtained. Now this time t is what? This t is t half, right? This t is t half. Now we have to plot the graph between half lifetime versus concentration, initial concentration A naught. The concentration is given along the x-axis and the time is given along the y-axis, right? So time is the y-axis here. That means we have to rewrite this equation because we have put A naught as the y, we assumed, but actually the t half is the y1. So the equation will be t half equals A naught plus 6 ln2 upon 4 divided by 4. This is the equation which we obtain. Now t half is taken as y according to the point, first option, and A naught is taken as the x. If we compare it with y is equal to mx plus c, right? So the slope will be 0.25, that is 1 by 4, and the intercept c will be equal to 6 ln2 by 4, right? ln2 is how much? ln2 is 0.693 into 6 by 4, and if we solve it, it will come out to be how much? 1.05. It will come out to be 1.05. That means the first option is correct. First statement is correct. Now second statement says if initial concentration of A is 8 molar, then it takes 5.1 minutes to reduce its concentration to 2 molar. That means now by using this equation, by using the same equation, the one which we are given, which one is it? This one, right? 3 ln A upon A naught plus A minus A naught is equal to minus 2t. if we use this equation, and initial concentration A naught is given as 8 molar, and at 5.1 minute it is 2 molar, right? So we can do one thing, we can find the time t by putting the values. If the time t comes out to be 5.1, then that statement is correct. So 3 times ln of A is given as 2, A naught is given as 8, plus 2 minus 8 is equal to minus 2t. Now again, this is how much? This is 1 by 4, and if I have to convert it into 4, I have to put the minus sign here. So it is actually minus 3 ln 4, right? Minus 6 is equal to minus 2t. So the time comes out to be how much? We can easily put all the signs as positive because there are minus sign on both sides. So it will be 3 by 2 ln 4 plus 3, right? So 3 plus ln 4 is how much? 2 into 3 by 2 ln 2. We can write like this. So 3 plus 3 ln 2. So it will be equal to 3 plus 3 into 0.693. On further solving it, it will be like this, right? So it will come out to be how much? 5.1 approximately. That means the time is actually 5.1 minutes as given in the option B. That means option B is also correct. Next, option C. The reaction follows the first order kinetics if the concentration of A is very small as compared to 3. We'll solve this option here only. If you look at the equation, rate equation, right? Rate equation is actually R is equal to 2A upon 3 plus A, right? It is saying if the concentration of A is very small as compared to 3. That means if A is very small as compared to 3, then A plus 3 is approximately equal to 3 only, right? So we can easily modify this equation and it can come out to be 2A upon 3, which implies R is equal to 2A by 3. Now here the concentration power is 1, right? So it will be first order kinetics. It will be following first order kinetics. That means option C is also correct. Next, option D. If the concentration of A is much greater than 3, then the plot of T half versus A naught is a straight line appears to be passing through origin. Okay, let's try to prove this statement. The rate equation which is given to us is, for option D, the rate equation is given to us 2A upon 3 plus A, right? Now what is it saying? It is saying that if the concentration of A is much greater than 3, that means A is very much larger value than 3. In that case, 3 plus A will be approximately equal to A only, right? So rate equation R is equal to 2A upon A. This is how we write it. A cancels with A, which implies R is equal to 2. That means the rate is equal to something constant, right? And this equation is for what? This equation is for zero order reaction. And in zero order reaction, we know T half is how much? T half is equal to A naught upon 2K. This is the actual zero order reaction for T half. So if we try to plot the graph between T half as given in the option D and initial concentration A naught along the x-axis, the graph will be passing through origin like this with a slope of 1 by 2K, right? That means option D is also correct. So that means in this question, all the options A, B, C and D are correct. I hope you understood this question and I hope you understood how to approach this problem. For similar such problems, stay tuned. Have a good day.